Very good morning, children. You all have studied about polynomials in 9th standard, and we shall continue from where we stopped in 9th standard. Recall, what is a polynomial? Do you know who is the father of polynomials? A Greek mathematician by name Diophantus. Phantus, a Greek mathematician by name Diophantus from Alexandria. He is considered as the father of polynomials, as he was the first mathematician to study about these. Now, what is a polynomial? Did you recall the definition of polynomial? An algebraic expression of the form P of x is equal to a naught, a1x plus a2x squared and so on plus anx to the power n, in which variables involved have only non-negative integral exponents, is called a polynomial in x. What do you understand by this statement? Any algebraic expression of the form P of x equals to, that is, P is for polynomial in variable x, a naught means here the variable has its power 0, a1x1, the variable x has its power 1, power 2 and so on, power n. This kind of algebraic expression can be called as a polynomial. Very clearly it states that in which variables involved, here the variable is x, a0, a1, a2, an, they are all coefficients of these variables. He says the variables involved have only non-negative integral exponents. That means non-negative means positive. Integral means what? We say, see, he is an integral part of the team. Means necessary, absolute necessity, or it is the whole. So that means here these are all non-negative integers, in other words. Okay? Integral part means you should understand that they are all non-negative integers. Supposing the power is a negative integer, then that particular expression we don't call it as a polynomial. Now, for example, I write here x squared plus x. This is a polynomial. 2x to the power minus 1 plus 6x. This is not a polynomial. Okay? Or 1 upon x squared plus 2x plus 3 is also not a polynomial. Power has to be, I write x to the power 4 plus x squared minus x plus 1 is a polynomial. You have to observe, if I have two variables, say x plus y, we don't call it as a polynomial, because any algebraic expression which is in this form, where there is only one variable, but that variable can be repeated any number of times. Each time when that variable is repeated, the power or the exponent or index should be a non-negative number, means positive integer. If it is a negative integer, we don't call it as a polynomial. Now, what are the different types of polynomials we come across? Now, at least we shall remember these three types of polynomials. One is linear polynomial. A linear polynomial is of the form ax plus b. This is the general form of linear equation. X is the variable, a is the coefficient of x, b is constant, ax plus b. Degree is 1. And what do you mean by degree of a polynomial? It is the highest power of the variable in a given polynomial. In a given polynomial, if the highest power is 1, then we say that it is a linear polynomial. And example 2x plus 7. Then quadratic polynomial. What is the general form of a quadratic polynomial? ax squared plus bx plus c, we say it is a second degree polynomial. If the highest power of the variable is 2, then it is called a quadratic polynomial. Example, I have given 2x squared minus 6x plus 1. Then cubic polynomial. What is a cubic polynomial? It is a polynomial in which the highest power of the variable is 3. So we say its degree is 3. Cubic polynomial degree is 3. And the general form is ax cubed plus bx squared plus cx plus d. So example, I wrote x cubed plus x squared minus x plus 1 is an example. So these are all the types of polynomials and their general form, and the degree you have understood it is the highest power of the variable, that's called degree, and some examples we wrote. Now what do you understand by this term value of a polynomial? What do you mean by value of a polynomial? If a polynomial in variable x, if p of x is a polynomial in x and k is a real number, then the value obtained by replacing x by k in p of x is called the value of p of x at x is equal to k. It is denoted as p of k. See, p of x in simple terms, p of x is a polynomial. P of x is a polynomial. Suppose k is a real number, and if x, the variable x in the polynomial is replaced by k, and that means in that given polynomial expression, wherever there is variable x that is to be replaced by k, then the result what you get is p of a, which is actually the value of the given polynomial. Right, let's we will consider some examples also to find the value of a polynomial. Say for example, I write p of x is equal to 2x squared minus 5x. Now that k is a real number, it can be, let's say, p minus 2. What is the value of p of minus 2? Where there is x, you need to substitute minus 2. 2 I must keep it as it is. So minus 2 the whole squared minus 5 into minus 2. 2 into minus 2 the whole squared minus 5 into minus 2. Now this is equal to 2 into minus 2 whole squared is 4, minus 2 into minus 2, minus into minus plus, 5 2s are 10. So here 4 2s are 8 plus 10, 18 is the answer. Okay, the value of p of minus 2 is 18. I repeat, if I have to find p of minus 2 in the given polynomial, wherever the variable x is there, replace it by minus 2. So 2 into x squared becomes minus 2 the whole squared minus 5 into, in place of x you put minus 2. What do you get? 2 into minus 2 whole squared is 4, 2 into 4 8 plus 10. So 18 is the answer. Agreed? Now let's take one more example. Fx is equal to 2x squared plus 2x cube plus 3x squared minus 11x plus 6. 2x cube plus 3x squared minus 11x plus 6. Find f of minus 1. So this is equal to 2 into minus 1 the whole cube plus 3 into minus 1 the whole squared minus 11 into minus 1 plus 6. Okay, so this is equal to 2 into minus 1 into minus 1 into minus 1 minus 1 plus 3 into minus 1 the whole squared is plus 1 minus into minus plus 11 plus 6. So minus 2 plus 3 and 11 plus 6, it is plus 17. Now 17 plus 3, 20, 20 minus 2, it is plus 18. So the answer is 18. This is how we can find the value of the given polynomial substituting k, which is a real number, for the variable. Okay. Now, what do you mean by 0 of a polynomial? What do you mean by 0 of a polynomial? 0 of a polynomial. If p of x is a polynomial and k is any real number such that p of k is equal to 0, then k is called a 0 of the polynomial p of x. Understand? P of x is a polynomial, k is any real number such that p of k is equal to 0, then only we can call k as the 0 of the polynomial. Now take for example, we shall have an example like this. I write p of x is equal to x square minus x minus 2. Let me take an example like this. P of x is equal to x square minus x minus 2. Now substitute for x 2. If I substitute for x2, because 2 is one real number in place of k, 2 squared minus 2 minus of plus 2 minus 2. 4 minus 2 minus 2. So plus 4 minus 2 minus 2 minus 4, you got 0. Since you get the result 0, for the value of x2, we say that the real number 2 is the 0 of the given polynomial. Correct? It is called the 0 of the given polynomial. Now, in fact, if you consider this as a quadratic equation, say x square minus x minus 2 is equal to 0. You know how to split the middle term and factorize. It is x square minus 2x plus x minus 2x plus x. When you multiply the first term and the last term, minus 2 into x squared minus 2x squared. You need to split the middle term into two parts in such a way that the product of the two parts becomes equal to minus 2x squared. So accordingly it is minus 2x plus x. Minus 2x plus x gives you minus x. If I multiply these two, I should be getting minus 2x squared. So x squared minus 2x plus x is equal to 0. Group them, minus 2 is equal to 0. Group them into two parts. Remove x common. You get x minus 2 plus 1 into x minus 2 since nothing is common. So x minus 2, the common you remove, and what is left here x and there plus 1, x plus 1. So you equate each factor to 0. If I equate x minus 2 to 0, then x is equal to plus 2. If I equate x plus 1 to 0, I get x equals to minus 1. So plus 2 and minus 1 are called zeros. 2 we have shown that it is a 0. Now minus 1, is it a 0 of this given polynomial? Verify. P of minus 1 is equal to x squared is minus 1 the whole square minus of minus 1 is the value of x minus 2. Minus 1 squared is 1, minus into minus plus 1 minus 2. 1 plus 1 it is 2 minus 2. The answer is 0. 2 minus 1 it is 0. Agreed? So this is how, see, factorization you must have learnt in your lower class. So this is how we can actually find the zeros of the polynomial. So you need to consider a real number k, and when you substitute that real number k to the variable of the given polynomial, if you get the result 0, if you get the value as 0, the real number which is substituted for the variable x can be called as the 0 of the polynomial. If it is a linear polynomial, there can be maximum of 1 0. If it is a quadratic polynomial, there can be maximum of 2 zeros. If it is a cubic polynomial, there can be a maximum of maximum of 3 zeros if it is a cubic polynomial, and so on. Now here I have written these sums. Second example, x square minus 3x minus 4, and substitute, that is p of x is equal to x square minus 3x minus 4. Substitute for x minus 1 and see whether minus 1 is a 0 of the given polynomial. Now, this is the second sum for you to do. Third sum, same polynomial p of x is equal to x squared plus 14x plus 48. Okay. Then fourth, p of x is equal to x squared minus 3. Now what you must do, you just have to find the factors and each assume that x square minus 3x minus 4 is a trinomial expression, and you have learned how to not in this x value is minus 1, you just have to substitute, and if you get the result 0, we can say that minus 1 is a 0 of this particular polynomial. When you substitute for x minus 1, if you don't get the result 0, then minus 1 is not a 0 of this particular polynomial. Here I am talking about this x square plus 14x plus 48. You need to factorize this. Factorization you have learnt in the lower class. Apply that rule. Multiply the first term and the last term, that is 48x squared. Split the middle term into two parts in such a way that their product becomes 48x squared. So after factorization, you get two factors, equate each factor to 0 and it becomes a simple equation. Transpose the numerical value to the other side, you get the value of x. You get two values of x. Now those two values separately, if you substitute for x, you get the result 0. Hence, we say that we conclude that quadratic polynomial has two zeros, maximum of two zeros. Now one more line, this is also a quadratic polynomial, x squared minus 3. What you need to do, this minus 3 can be written as, see here, p of x is equal to x squared minus 3 can be written as x squared minus root 3 the whole squared. X squared minus root 3 the whole squared. So this is x plus root 3 into x minus root 3. Applying a squared minus b squared identity which you have learnt earlier. So a squared minus b squared equals to a plus b into a minus b. So x minus root 3 into x plus root 3 we get. Equate each factor to 0. X plus root 3 is equal to 0. Then we get x is equal to minus root 3. And plus root 3 goes to the other side, minus root 3. Similarly, x minus root 3 is also equated to 0. So x is equal to, and minus root 3 goes to the other side, plus root 3. So what you need to do now, so what I wanted you to do at home, I have only done it. Same way you will do here, this sum. Here you need to just substitute for x minus 1. Now after this what you must do, I want you to do verification. How do you verify? Take this x square minus 3, substitute minus root 3 here and find the result, see whether you get 0. Again substitute plus root 3 here in place of x, see whether you get 0. If you get the result 0 in both the cases, you have to get, because those are that's a solution, that forms a solution if it was a quadratic equation. Now minus root 3 and plus root 3 become the zeros of this particular polynomial. If you get the result 0 when you substitute for the variable. So we shall continue in the next class. Thank you.